All right, so adding and subtracting radicals. Kind of the theme of today that I want to keep in mind is we are looking for like terms. You've heard of like terms before? Yes. Usually you think of like terms in the sense of if you have 3x plus 4y minus 2 plus x minus y, that you would look for what? The x's would be considered like terms, right? 3 and 1 would be 4x. What else would be like terms? The y's, so 4y minus y would be minus 3y. And then if there were any other plain old numbers, those would go there too. And that's what you would end up with, right? That's probably how you've seen them before. Well, like terms can also have matching radicals. In other words, if I have a radical 6 and another radical 6, those are like terms. So I would assume that there's a 1 in front of those. What do you think those would add to get?
Radical 12.
Not radical 12. We can't treat it the same way as multiplication. Like when you do, if you have x plus x, you don't have x squared, right? Because that's multiplication. What do you have? You have 2x, don't you? So if I have 1 rad 6 plus 1 rad 6, I have 2 rad 6. So the radical isn't actually going to change. It's just what we call the coefficient, the number in front of the radical that's going to change. So? No? Well, we got a few more examples to make it get there. Okay. How about this one? Do the radicals match? So I know my answer is going to be something radical 3. What is negative 2 plus 3? I don't have to write a 1, do I? I could and it wouldn't be wrong, but I don't have to. Okay. In number 3, what are my like terms? The radical 3 and the radical 3. So if I were to add the coefficients, what do I have? 2 radical 3, and then what? Plus radical 2. That one doesn't have anything to combine. Now, could you write your answer like this? Could you say radical 2 plus 2 radical 3? Absolutely, means the exact same thing. Okay? Doesn't matter which one you write first. Okay? All right, what about this one? Are there any like terms? No, they're all different. So here's my suggestion. When they're all different, see if any can simplify. So in other words, I can't draw a tree for 5. I can, however, draw a tree for 12, can't I? That would be 6 and 2, 3 and 2. What would that become? 2 radical 3. 2 radical 3. So I'm going to keep this all lined up here. I have 2 radical 5 minus, and then instead of radical 12, I simplified it to 2 radical 3. Can I simplify this one?
Yes.
Radical 20. Let's see, that's 4 and 5. 2 and 2. What comes out?
2.
A 2, but there's already a 3 out there, or a negative 3, I should say, which means I'm going to have a 6 outside. You follow? Because I'm taking the 2 out and multiplying it by the 3 that's already there. So now that I have those 2 simplified, do I have like terms? Yes. I have 2 radical 5 and negative 6 radical 5. Now it doesn't matter whether I write the radical 3 term first or the radical 5 term first. What do I have as far as radical 5 though? 2 and negative 6 would be negative 4 radical 5. And then I have a minus 2 radical 3. What would it look like if I wrote the radical 3 term first? Negative 2 radical 3 minus 4 radical 5. So things that might not start out looking like terms, you can simplify and they become like terms. Okay? I want you to try 5 and 6. You done? Okay. So, can I draw trees for any of these radicals in number 5? I could draw a tree for 6, but there's no pairs to take out, right? So let's just look and see what we have that matches. Negative 2 radical 6, positive 3 radical 6, and negative 2 radical 6. So negative 2 and positive 3 is 1 minus 2. So I have negative 1 radical 6, which we would write like that, correct? This guy doesn't have a partner, so he's just going to stay plus 2 radical 3. How would this look if I wrote it the other way? Two radical 3 minus radical 6. So whatever sign, plus or minus, comes in front of the term has to still come in front of it here. So this negative sign here has to still be in front of the radical 6 if you write it the other way. Okay. Number 6, can I draw trees for any of these guys? I could draw a tree for 6, but again, there's no pairs to take out, right? What do I have for like terms? This guy and this guy. Any others? Okay, so let's see. 3 radical 2 and 3 radical 2 is 6 radical 2. And then I have a plus 3 radical 5 and minus radical 6. Yes? Okay. What about 17 and 18? I'm sorry, 7 and 8. Sorry, I was looking here and thinking and talking at the same time. That doesn't work very well sometimes. What about 7 and 8? Why don't you try those? Now again, please try to do these without a calculator, because I know that some of those calculators have that, they'll already do the simplifying for you. Okay, you ready for me to jump in here a little bit? Can I draw a tree for 18? That would be 9 and 2, and then 3 and 3. So, if I ignore the rest of this, what does negative 2 radical 18 become? I can take out a 3, which I'm going to have to multiply by the negative 2, so that gives me negative 6 radical what? 2. Okay, so I've changed the way that guy looks. Do I need to change the way this guy looks? So I'm going to keep him the same. So I'm done with those two. This guy, I need to draw a tree for 54. 54 is 2 and what? 27, 3 and 9, 3 and 3. What can come out? A 3. There's already a negative 2, so 3 times that negative 2 gets me negative 6 radical what? 6. And then my minus radical 2, can't draw a tree there. So what do I have for like terms? It looks like I have negative 3 radical 2, negative 6 radical 2, and negative radical 2, right? Those are all like terms. So what do I get when I combine all those? Negative 3 minus 6 is negative 9. Minus 2 is, I'm sorry, minus 1. Negative 10 radical 2, and then minus 6 radical 6. So? Now, this one's kind of interesting because, yes, I can draw a tree for 18. However, aren't all 3 of these like terms? So let's combine them first and then draw the tree. So if I have negative 3 rad 18 plus negative 2 rad 18 plus negative 2 rad 18, what do I have? Negative 3, 4, 5, 6, 7 rad 18 minus rad 6. Yes? We good there? Can I draw a tree for 6? I can, but are there any pairs? No, nothing's going to come out. 18 would be 6 and 3. 6 would be 2 and 3. So I can take out a 3, which means this term becomes what? Negative 21, because the 3 I have to multiply by the 7. So negative 21 radical, not radical 18. Come on, Franklin. Negative 3 radical what? 2 minus radical 6. Now, there's no like terms to combine, so that's my answer. Isn't this answer still correct, though? It is technically, but it's not fully simplified. This is where I want you to go. Make sure all your radicals are as simple as they can go. So? Okay, so now I'm going to touch a little bit on the multiplication that we did yesterday. But the multiplication yesterday, we would just leave the terms out. We wouldn't actually combine any like terms. So now we're going to add the step of combining like terms. So I'm going to start off with a distributive property problem. If I distribute this, what am I going to get? I have 4 times 1, which is 4. Radical 2 times radical 2 is radical 4, and I'll deal with that in a minute. 4 radical 2 times radical 3 would be what? 4 radical 6. So only when I'm multiplying do those numbers under the radical change. Let's see, what can I do from here? Hint. Square root of 4 is 2. So this is really 4 times 2. What is 4 times 2? Plus 4 radical 6. That's where we got to go. Capiche? What about this guy? This was the one where I have to like double distribute, right? So let's see. Negative 4 times negative 3 is what? Positive 12. What's negative 4 times radical 3? Negative 4 radical 3. And then if I do the other one, that would be radical 3 times negative 3. What would that give me? Negative 3 radical 3, because I have a negative 3 outside and a 3 inside. And then what's radical 3 times radical 3? Positive radical 9. So there's a couple things going on here. First off, I have some like terms. Do you see those? So what's negative 4 radical 3 and negative 3 radical 3? Negative 7 radical 3. I have a 12 out in front here. And what is radical 9? So I have a plus there. That's plus 3. Do I have any more like terms? 12 and 3. What is 12 and 3? 15 minus 7 radical 3. And technically, if I wrote it backwards, I could have negative 7 radical 3 plus 15. That would also be a correct answer. Doesn't matter which one you choose to write first. So? Okay. I'm going to skip number 11 for right now, and I'm going to do it after I do number 12. Okay. Double distributing again. I'm going to start off with, let me get my colors here, 2 times negative 3. What does that get me? Negative 6. Then what do I do? 2 times what? 5 radical 2. Well, this 2 is outside, so I have to multiply it by the 5. That's going to give me what? 10 radical 2. Yeah? Okay. Now I'm going to do the other part of the distributing. 2 radical 2 times negative 3. 2 times negative 3 is negative 6. Radical what? 2. And then 2 radical 2 times 5 radical 2. That's going to be a positive. 2 times 5 is 10. Radical 2 times radical 2 is radical 4. So we got some simplifying to do. First off, I notice these two are like terms, right? So I have negative 6 and then what? Plus 4 radical 2. 10 and negative 6 is 4. Yes? And then this guy, I have plus 10, but what is radical 4? Times 2. So what is 10 times 2? So I have negative 6 plus 4 radical 2 plus 20. Am I done? There's one more thing I can combine. Negative 6 and positive 20. What does that give me? Positive 14 plus 4 radical 2. And again, you could write your answer as 4 radical 2 plus 14, and that one is correct also. So? Okay, now I want to go to number 11, and my question is, what the heck do I do with number 11? What does that little square tell me I have to do? Times it by itself. Whenever I see that squared thing, that means I need to take this and write it twice. So it's really a double distributive property one. Yeah? Why don't you take a minute and work through that one and see what you can do. All right, so radical 2 times radical 2 is what? Radical 4. And then radical 2 times radical 3 is radical 6. Now if I do the second part of the distributing, radical 3 times radical 2 is radical 6. And radical 3 times radical 3 is radical 9. So, first thing I know, radical 4 is the same as 2. Here are my like terms. What do I get when I have radical 6 plus radical 6? 2 radical 6. Wasn't that the same as number 1? Problem number 1? Plus 2 radical 6 plus, what is radical 9? 3. Last thing I'm going to do is combine these last two like terms, 2 and 3. What is 2 and 3? So I have 5 plus 2 radical 6, or if you wrote it the other way, what would you have? 2 rad 6 plus 5. Okay? So? All right, your homework is a review of radicals, and it actually reviews everything that we've done with radicals. So it kind of covers a little bit of everything, all right? Happy studying.